Welcome everyone to a quick tech video here. I came across some interesting concept here, GRAID, from some technology startup or company here. And so they have a solution to accelerate kind of software rate, even on Linux. So that is not open source, it's a proprietary solution. But one detail is very interesting, which is why I particularly wanted to shout this out here. And we could implement this open source in Linux or our other systems if we wanted to. I hope they didn't pretend this, also some CES 2022 award. So the problem is that what they try to solve here is that on one side we have software rate, we ourselves usually use here with Linux, even in the new form of LVM2, for example. And software rate, of course, I personally prefer software rate because more flexibility, also total bandwidth, because hardware solutions, you have the problem hardware rate nowadays. All of those massively fast NVMe cards quickly saturate the PCI lanes, so there is not even that much high throughput hardware rate anymore. And the problem with software rate is, of course, all the parity computations. RAID 5, for example, the checksumming, and that takes quite some significant amount of CPU cycles, and that is where the solution comes in here. So they sell here a card, GRAID Supreme RAID, and I tell you already now what it is. So that is actually a freaking normal NVIDIA T1000. Where did I open that? Where did I even? Here. And so that is, as you see, an NVIDIA T1000 rebranded, a NVIDIA CUDA cores 896 up to 2.5 teraflops, 50 watts PCIe 3.0 by 16. And what they do with it is also improve performance, right? They claim here 4K random read writes, 16 million IOPS. Here with their solution, otherwise high-end hardware. So that is not the most interesting, can't forget this. But anyway, they claim here outstanding performance. RAID also compared, I mean, not only they claim here better performance than other solutions, but obviously also software RAID. Software RAID, of course, saturates the CPU kinda if you have many NVMe drives nowadays and enough I/O operations, then of course you saturate your CPU quickly, even if you have an epic Threadripper. And so the only thing is, well, it has amazing performance, right? But RAID is limited to 11 gigabytes per second, which is still more than other hardware RAIDs here. That comes from this NVIDIA PCIe interface here, that is PCIe 3 by 16, so you have a maximum throughput of nearly 16. So real life like 12, that is that. So the way that works, they have here also software composable infrastructure ready. So I'm not saying go buy this. I mostly want to shout out the interesting technical concept, which is actually something I said already multiple times, right? Even 3 years ago, I said I wished GPUs were more general purpose programmable. And I always, before I made these YouTube videos, I always called out for decades for GPU vendors release their hardware programmable reference manuals for open source people and other innovative people to implement their stuff, software, whatever. So yeah, I'm mostly calling this out from the software design standpoint and motivating people to write more interesting stuff. Because the way this works is, it looks like read is pure software RAID. We have here CPU, application memory, here operating system, this huge PCIe bus thing there, and here the SSDs. So that looks to me sort of probably, although actually wait a second, they say here RAID Supreme RAID. Maybe, I'm not sure. So I didn't buy this stuff yet. I only watched 2 other YouTube videos basically that claim that the performance numbers look in real life how they would be. Maybe if you share, like, and subscribe, eventually we become big enough to also buy this stuff and try it out. Or this company wants to send it to us. Actually, now taking a closer look, it looks like maybe this GRAID Supreme RAID is actually also programming. Wait a second, how should this work? This looks a little bit strange, I'm not entirely sure. Anyway, I would think the CPU programs the NVMe interface and does the read. So I would think the read is still pure CPU limited and utilized, and only the write is doing here the parity computations. I would also think so for reads they probably don't compute a parity, and as long as because otherwise these numbers don't add up, you can't have more read performance here of 110 gigabytes per second. That is of course more than PCIe bandwidth by 3.0 by 16, so that obviously can't parity checked. If you have a failure and you need to restore the parity, of course your performance will break, most likely throttle to just the PCIe bandwidth, unless they do this on the CPU, which wouldn't make the most sense. Anyway, on write is where the magic happens, the magic. So the write, they offload that here to the GRAID Supreme RAID TM, aka otherwise known as NVIDIA T1000. And there's nothing magic with this particular NVIDIA card, right? You could theoretically do that with open source stuff, with open source drivers if you re-implement this, and do the checksumming. So you have the data in memory, and then you general purpose, GPU general purpose program your GPU not to do the texture and lighting, but the parity computations. And this is how this is limited to the PCIe bandwidth, right? Because now the data goes bus mastered, here read by the GPU, parity data computed, and it's still a huge win, right? I have here some other storage review YouTube video that I recommend you watching. So they tested that, and I wouldn't make this video if I would not have other external people. I mostly wanted to show you the concept for some inspiration. So if this is true here as shown by storage review, 4K random read, for example, software RAID 5, they don't further specify. I would guess maybe that is an MD RAID, maybe not LVM2 RAID, although probably the performance is close. 2.9 million IO ops with 0.89 milliseconds average latency, goes up to like multiple times the performance here with this GRAID RAID 5, 8.8 million IO ops and decreased latency of only 0.23 milliseconds average latency. And write also goes up from, because software write, you are not PCIe bus bandwidth limited, but CPU parity computation limited apparently, and that goes up from 52 K IO ops to 863 freaking K IO ops, and latency going down. Also, the problem with this kind of reviews is this really like data? This looks a little bit suspiciously low. Because I really wonder if this is really data integrity safe, not like the Asahi Linux found with Apple of like, yeah, flushing, whatever. You wonder if that is really, like in case of power loss, not like data in flight and not like parity checked, and then you have some journal corruption because, yeah, GPU isolated write, YOLO, whatever, at least performance. That is always the thing, which is also why I personally wouldn't neither run the proprietary solution, which also has a problem. They have other interface programs and APIs, so you're not using the LVM2 stuff or MD RAID, so you're using the proprietary command stuff or whatever, so I can't recommend this, right? I wish those companies, that is also the problem as usual with Windows, and although this is supporting Linux, but in general, proprietary stuff is like, yeah, if you're not using the other infrastructure stuff, then it doesn't integrate with other storage management solution and so on. I anyway find this performance totally fascinating, and I have some more sense. Also, Linus Tech Tips of all people reviewed this already. They also found here good read performance and stuff, although the read performance should be fully CPU. I wonder if you could also accelerate, they don't, I mean, they show here RAID going there. I wonder if theoretically you could, from the GPU, write to, over the PCIe bus to the mapped memory of the NVMe controller and actually do the programming. This diagram doesn't show this, so here maybe I should probably make a blog post. Not sure if someone has done this. Also, I hope they didn't patent this. I mean, it's super trivial, right? This is simply GPU general purpose programming like we've done for 15 years and CUDA and stuff. So this is, in my opinion, not patent worthy. It's just like, why has nobody else done this? So far, also open source people, right? Maybe they're busy with pointer dereferencing and refactoring their C APIs. Recurring criticism here. So in my opinion, not patent worthy. In my opinion, nothing really new from offloading stuff like algorithms, like crypto mining, right? Extremely simply parity stuff, in my opinion, that should not be patent worthy. So maybe go ahead and write open source stuff. And maybe we should do. And I wonder, and this is also why maybe I should actually write a blog post, which I sometimes do. Also, I wrote a couple of blog posts just to have prior art because I'm not a fan of software patents. I wonder, maybe I should also research this Microsoft and Sony direct storage API stuff of accelerating, accessing resources for modern 3D engines and loading resources relatively straight from the storage controllers. Because I don't know whether this direct storage stuff programs the NVMe controller from the GPU. I would think not. I would think because that would need to be interface agnostic, that this direct storage stuff is still using operating system services for those storage drivers. But theoretically, I would think it should be possible, and maybe we should actually toy around with that, that the GPU, like any, not their GRAID branded NVIDIA, but any open source or otherwise GPU directly programs, like receives all the data, you offload all the programming, although the programming is not the most, but yet it's something theoretically. I also, again, I wonder, neither Storage Review nor LTT, Linus Tech Tips, have appear to have tested actual outage. So I have no values for how the performance degrades, the read performance degrades if it needs to compute parities because one or more storage drives go down. So yes, that is a card. As you see here, that is exactly the same that I think they show here, right? Even I think both Storage Review and Linus Tech Tips both mentioned it's a unbranded, as you see, NVIDIA card. So they even sent for review a, where would that be? Somewhere of, yeah, so they sent a non, yeah, there you have it, NVIDIA. LTT, Linus Tech Tips, they made the naive thing of, hey, can we plug in another card? I would expect, because whether it's in kernel or not, of course the storage, the proprietary storage software stack needs to directly program the GPU or relatively directly program the GPU for the parity computations. Of course you can't just swap the NVIDIA generation. You would need to have the shader compilers and the compilers there for the GPU stuff interface. And so obviously it's like, yeah, why do they even try this? They tried to plug in the display, and that of course worked because it's just I mean, it comes with a metal backplate that doesn't have display slots, but if you unscrew it, of course you can plug a display in and freaking has display output if you wanted to. Some more notes here to conclude that. That I mentioned this a couple of times, and I wish we would have had more advancements with that. The next Cube 30 years ago came with a Motorola DSP65K for co-processor stuff. The previous video rendition Verite was one of the first 3D accelerators and fully programmable with a MIPS-like instruction set architecture. And I said this multiple times, that I wish in general the stuff would be more flexible programmable. Of course, the problem was proprietary drivers and basically all the Windows stuff, drivers, and not disclosing hardware specifications that the open source people always ask for, somewhat killed that innovation. But if those co-processor cards, whether in the Motorola 56K is even of course fully documented and has an open source compiler. And I actually, previous video, I 20 years ago sold myself an own ISA card for 56k DSP acceleration. My point is, we could offload so much more stuff for a long time and compute stuff there. Of course, it happened a little bit, but so far the GPU stuff, the heterogeneous computing here was mostly like graphics, like massive bandwidth algorithm stuff of hashing and similar, or chemical and biological simulations and stuff. And from that point of view, it is kind of an innovation. I don't really want to, I mean, it's sort of obvious, like, why did nobody else do it? I just, for the software patent situation, don't really want to give it that much credit, because again, it's super simple travel of freaking parity computation, some 4K or 16K or whatever blocks there. But nonetheless, not sure if others have done that, and I wish more people would do that. And that is also why I have this operating system series here of what is innovation, what innovation was there, what should we innovate in, what is there to innovate, and that is one of the more interesting things. And theoretically, we could write whole operating systems supporting that you transparently can interface other coprocessors, because currently they all need to be specifically programmed, of course also due to the nature of the proprietary drivers. And I wish there would be more. There was, like, did I open that somewhere, like Barrelfish? The usual summary of heterogeneous computing systems, like data parallelism, QDA-C and stuff. And I wish for a long time this would be one level lower, not like this higher level libraries, but more a whole system, so that you maybe even with a virtual language, because the problem is also, or like even C, I mean, you can interface this here with QDA-C, for example. And this here only lists like APIs, as you see here, OpenCL, but these are only user space level APIs and frameworks. And what I, for a long time, probably hopefully mentioned previously in these videos, wished that would be like all the resources more visible. I mean, very theoretically, you have even ARM processors on serial ATA or NVMe drives, and of course they run their dedicated firmware on the NVMe drive. So you have even there, even on Apple, actually Markan said, I didn't even think about this, but according to Markan, Factor Martin of Asahi Linux, there are even multiple ARM coprocessors, ARM 64-bit coprocessors, and multiple of those for all the storage things. So even on the Apple silicon, where normally on other systems you would have ARM controllers in your NVMe drives, even on the Apple M1, you have multiple additional not operating system directly visible or controllable ARM processors to run the firmware like storage. And sure, one thing is you need stable and reliable firmware, which in this NVMe drives is always vendor proprietary. But there was research and articles over the years, even to like high performance and journaling. Theoretically, you could even put file system and journaling features straight into the firmware if this would be more open, right? If we imagine we would have an even more open compute system and all those resources, like not, because currently is, do I have this here even probably like here? Currently we have direct access only to the CPU, a little bit indirect and proprietary driver guarded access to the GPU, and beyond that it's all mostly inaccessible. And it would actually, for use cases like this, interesting to make use of all this additional coprocessor computing power for tasks like this, or others. Imagine of all the other algorithms you could offload there, if that would be like more standardized. Because even in this solution, right, currently you can only use their solution with their specific GRAID branded or NVIDIA T1000, where was it? Somewhere up here, T1000. But then you still need the license, right? Not really sure if they sell you a license, as usual. Anyway, found this really interesting. Again, didn't review this much further, just, again, really interesting summary, and leave in the comments below, as usual, what you think of innovation and software. There was actually one thing, Barrelfish, or there are certainly others, although this is no longer active as we've seen recently, but I didn't quite looked into that the last years, but I remember it had the idea of exposing, like, manage and exploit heterogeneous hardware resources, but maybe it could be marketing, but yeah, just as a data point. As far as my understanding of memory goes, there were like systems that theoretically had the motivation to utilize those resources better. Anyway, if you ever test this or have other comments and stuff, always leave them below. Hope you learned something sort of interesting stuff. Don't forget to subscribe, and I hope to see you soon for the next fun stuff to come.